So I just sit here and wait until it's 1:20.
Again?
I just sit here and then wait until 1:20.
Yes, yes. Okay. I start streaming, but when a student come in. Okay.
I can start when the students come in or not yet. I start
Yes.
at 1:20. Exactly.
Yes, you can start after when students come in a lot.
They come in a lot. I can
Yes,
start. Okay.
yes. Okay. A student. A student can hear you. Okay.
Operation. 8 viewers.
Saan ba nakikita?
Current viewers. At 15, you can mention and read their names. It was safe now. Safe.
Sige naman.
It's time to read their answers. It's the online M6. Yes, but they can hear you.
So much.
Hot.
Is it broken?
I think so.
35.
Hello, Sutida.
You have 37 viewers. You can talk to them.
Kikawi.
You can start talking actually. And then you can start teaching. 120. So good afternoon. Our class today is about science.
60.
No, 42. Okay, 4 minutes. Back. Okay.
Huh?
Alex, he's young now. Okay, start talking now. Students, please write your name.
Hello, students. I can see you, but I cannot hear you. This afternoon, Teacher Jim won't be around. He's absent. So instead of studying additional English, I will take over the class and teach you science. And our topic this afternoon is about galaxies. Now, I have some questions for you to answer later on. Now, if you would like to earn some points, you can write your answers on the comment. You can say something. And then later on, I will review the comments and give you points for your listening skill, because we just started our lesson when the classes were canceled. So this is your chance to earn points for listening. Tanjira, I can see you. Jutarat, room 6/4. Tanjira, Kanison, Chantip 6-1, room 1. Akapon, room 6. Sirapap, room 8. Sirikan, room 5. Tanapon, room 3. Okay, so we're going to begin the lesson now. Okay, who else are here? Me, room 3, room 4. Ponkamon, room 3. Pomnara Budi, room 5. Anusha, room 2. Aracha, room 8. Manasanan, room 6.
You can transition. Yes. Okay.
This one they can see.
Yeah, I can see you already.
Okay, students, we're going to start the lesson now. As I mentioned earlier, we're going to do the topic on galaxies. Actually, we're supposed to begin the lesson on the formation of the universe, but it's quite difficult to do it online because there are so many technicalities involved. So I just started with this topic on galaxies, and then when the school opens again, and then we can meet face to face, that is the time we're going to do the topic on formation of the universe. Okay, we have more people coming in. Tanin, Panapon, Sutipong, dapat. Achipon, Surachai, Bunyawi. Bunyawi, I can remember you, room 7. Ponichapat, Warawit, Duang Kamol, Tin,
Morawit, I can remember you.
Chanchanok, Napapon, Waramate, room 2. Patanan, room 2. Tanyapak, room 3. Panida, room 8. Okay, let's see how many do we have now. We have 46 online viewers. That's Sarapon. Okay, hello everyone. Welcome to your science online class. Okay, I will be teaching you this period only because your additional English teacher is not around. Okay, so let's start with the lesson. We're going to deal with the topic on galaxies. Now, before we go to the topic on galaxies, I would like to introduce you to some vocabulary that you will encounter during this lesson. Let's start with the first one. We have the first vocabulary, which is galaxy. When you say galaxy, this one is a collection of three things. We have gas, dust, and stars, held together by what we call gravity or strong gravitational force. So you try to remember, there are three things in a galaxy: gas, dust, and stars. Now, gas, dust, and stars were formed during the formation of the universe. Okay? So,
You can write.
You can write in circle if you want to give emphasis.
okay.
But,
So,
but you
as I
can,
mentioned earlier, gas,
Oh,
dust,
the-
and stars
Okay.
Not erase.
were formed during the formation of the universe. So this one, and this one. So you might not have any idea about this one yet because I have not started teaching you. We will do that when the school opens again. So these three were formed at the time that the universe was forming. Okay, vocabulary number 2. We have star clusters. Star clusters simply means a grouping of stars. Okay, a big group of stars. But if the group of stars is small, we call it star system. So the star clusters refers to a large group. Okay, large group of stars. And the smaller one is called a star cluster. So you can see here, this is your star cluster. You can see there are very few stars present. And here you have the globular star cluster. Lots of stars here. Okay, let me see. Now, if you have any questions or comments, you can say something on the comments part of this lesson. Please feel free to ask questions. Okay, number 3, we have the interstellar. When you say inter, it means in or occurring between the stars. So if these are your stars, these spaces here between the stars is what you call interstellar. Okay, that is number 3. Okay, vocabulary number 4, we have the central bulge. When you say central bulge, this is the group of stars found at the central part of the galaxy and is normally found in what we call spiral galaxies. Normally, you cannot find it in irregular or elliptical galaxies. If there is, it's very rare. So this part here is your central bulge, this one. Okay, and then the middle part here is the nucleus. Okay, this one is the arm. Now, I will give more information about this one when we go to the topic on spiral galaxies. So the bulge is right here at the center, and there's a large group of stars in it. Okay, vocabulary number 5, we have the term elliptical. When you say elliptical, the shape is like an ellipse. It's not circular. So we say that the planets move around the sun in elliptical orbit. If you remember our lesson before the school closed, we have this theory that was formulated by one of the astronomers during the time. You remember there are two. One theory states that the Earth is the center of the solar system and the sun and other planets move around the Earth, which according to the theory is wrong. And there is another theory wherein the sun is the center and the planets move around the sun in elliptical orbit. So planets move around the sun in elliptical and not circular orbits. Now, I'm going to give points to students who can tell me or who can remember what is the theory that says that the sun is the center of the solar system and the planets move in elliptical orbits around the sun. Okay, you can give your answer. What do you call the theory? Okay, what do you call the theory? Okay, write your answer on the comment section. Okay, we go now to the formation of galaxies.
Yes.
You want to
Never mind.
You went to this. Okay.
Okay, students, let's move on now to the formation of galaxies.
You just wait for chat
Okay,
because this delay.
okay.
Okay.
All right, let me see. There's a comment here. It's from room number 3. Coxapon. Your answer is solar system. No, it's not solar system. It's not. You cannot remember. Maybe your notebook is with me in school. Okay.
heliocentric theory.
I'm on one. No comment. Who is this one? Bon
Borinchai.
Bodinchai. Room number 1. Okay. You get the point. We call it heliocentric theory. Okay, you get the point. I will give you 5 points for your answer. Okay. So this is room number 1, number 29. When I have some questions, please write your answer so you earn the point. Hello there, Pulpachara, Chetida, Pulpachara, room 6, Chetida, room 3, Kitipat, room 8, Nitichaya, room 2, Kitsada, room 3, number 21, Siruit, room number 6. Okay, let us move on now. So, we're going to discuss now the formation of the galaxies in 5 simple steps. So, in step number 1, we have here the collection of dust, gas, and young stars. Okay? What happened in step number 1 was that all of this collided. Now, after the collision, there is what we call a quick rotation. Okay, there is a rotation and collision among these 3 materials at the center. So, the center part of the galaxy is beginning to form. And then in step number 3, there is a contraction. The contraction happens. And then we form what we call the galactic disk. Students, this is the center. And this one is the disk, the one at the side. Something like it's flat. We call that the galactic disk. And then finally, in the last part, you can see here that the faster the central part moves, you form what you call the arms of the galaxy. Here, these are the arms. I will show you a clearer picture later on as we go along. So step 1, you have the materials, gas, dust, and young stars. And then after that one, they begin to rotate. And in that rotation, you form a disc. Okay? That part became flat, the side part become flat, and then the last part is the formation of the arms. Okay, if you have any comments or questions, please write it on the comment section. What is this one? OC Indipico?
No, they're not. They're just, they just entered the line. Not mine.
Pasachon, room 3. I know you're trying very hard to answer, but you cannot remember. Okay, never mind. Never mind. All right, let us move on now to the types of galaxies. Galaxies are classified according to their shapes. Number 1, we have spiral. Number 2, elliptical. Number 3, we have irregular galaxies. Now, if you have some time, you have a pen and paper with you, you can take down some notes also. So when you come back to class, you will be advanced. Again, I repeat, galaxies are classified according to their shapes. The 3 classifications are spiral, elliptical, and irregular galaxies. Sarut, hello. Room number 8, number 73. Kampon, hello there. Room 3, number 1. Chanita Pon, room 6. Room 4, number 5. Okay, let's take a look now at the spiral galaxy. Now, I have here a clearer picture of what a spiral galaxy is like. So, one main characteristic of a spiral galaxy, it has a central, dense area. So, this one here is the central dense area. And you can see the arms is spiral. It goes like this. And the arms are in star formation. So, this is the bulge. Okay, the dense area is what you call the bulge, if you remember in our vocabulary, and these are the arms. Okay, I have an additional information about the spiral galaxy. The first information is that it has a central flat disk. The disk is flat and it's central, and it's made up of interstellar matter of young star clusters, mostly in the arms. Students take note that these arms is the site of star formation. So if you see that the galaxy is dim, it means that galaxy is old and there is not so much star formed. Spiral galaxy is not the type of galaxy where most of the star formation takes place. It's in another type of galaxy. But I would just like to emphasize that most of the star formation in this type of galaxy occurs in the arms. Okay. Second fact, it has a central bulge or nucleus containing older stars. So older stars are found there at the center, or what we call the bulge. Younger stars or star formation takes place in the arms of the spiral galaxy. Sirawit, room 8, hello, number 68. Vinrada, room 3, number 18, hello. Patira, room 4, number 31, hello. Kitin, room 6, number 3, hello over there. We have more coming in. Paricha, room 4, number 27. Okay, let's move on to number 2. We have elliptical galaxies. Elliptical galaxies has the shape of something like an egg to what we call long, narrow shape or cigar shape. So you can see here, the shape of this galaxy is like an egg. And most of the stars here, younger stars, are formed outside. Now, elliptical galaxies are denoted by the capital letter E. They are given a number from 0 to 7. Okay? Now, if it is EO, that galaxy is shaped like a circle. And E7, it looks very long and thin. Okay, let's look at these pictures. So you will see EO galaxy is rounded, just like it's described before. And this is E7. It's elongated. And all other galaxies have varying shapes depending on their number. We will not discuss this in detail. okay? Because this one, it focuses more on the general aspect of the subject matter. I just want to show you the picture so you know how it looks like. So these galaxies are designated by the letter E with their corresponding numbers, and their corresponding numbers describes the shape of that particular elliptical galaxy. Number 3. Is this one? Chris Chot, room 1, number 22, hello. Tanot, room 3, number 2, hello. Apiwit, room 3, number 5. Amitra, room 1, number 28. Panita, room 7, number 28. Nicha Kamol, room 1, number 5. Suwijak, room 5, number 11. Pisawat, room 5, number 8. Amon, room 3. Amon, you're number 3. Hananon, room 2, number 25. Okay, let's move on to the third one. We have irregular galaxies. Irregular galaxies does not have a lot of common features. The shape is very irregular. I have here 2 important facts about the irregular galaxies. The first one, they are deformed. Okay, originally they are either spherical or elliptical, but they were deformed by galaxy collisions or the gravitational attraction with another galaxy. So these are the 2 reasons why we have irregular galaxy: collisions and gravitational attraction with another galaxy. Now, an example of this irregular galaxy is what we call starburst. Try to remember that if the galaxy is so bright, it means it is undergoing the formation of young stars. Okay? And this formation of young stars, it goes on for a short period of time only. So among the 3 types of galaxies, the one that has the most star formation is the irregular galaxies. Okay, if you have any questions, please send it to me in the comment section. Yes, I let them watch the video.
Can you face the screen? But
Hi, I'm Emerald Robinson. In this What Is video, we'll take a look at the largest known visible objects in our universe, galaxies. Galaxies are massive, gravitationally bound collections of star systems, gas, dust, and a mysterious substance known as dark matter. Dark matter, which some scientists believe could account for more than 90% of the universe, cannot be seen, but still exerts
galaxies. I do not own this video, and it will be used. It's owned by YouTube, and I will be using this one only for educational purposes.
Hi, I'm Emerald Robinson. In this What Is video, we'll take a look at the largest known visible objects in our universe, galaxies. Galaxies are massive, gravitationally bound collections of star systems, gas, dust, and a mysterious substance known as dark matter. Dark matter, which some scientists believe could account for more than 90% of the universe, cannot be seen, but still exerts gravity. Just as the objects in our solar system revolve around our sun, objects in a galaxy revolve around a galactic center. Most scientists agree that at the center of most galaxies is a supermassive black hole. Just how many galaxies exist is up for debate. Scientists believe that there are more than 100 billion galaxies, possibly hundreds of billions. Galaxies can also have up to 100 trillion stars, although dwarf galaxies exist with as few as 10 million stars. Besides varying sizes, galaxies come in different shapes, too. Spiral galaxies like our Milky Way consist of a central concentration of stars, known as a bulge, rotating around a galactic center. Arms spiral outward like a pinwheel. Earth is located in the Orion arm of the Milky Way galaxy. Elliptical galaxies range in shape from nearly spherical to so elongated they take on a cigar-like appearance. The star-making process has all but ended in these older galaxies. An irregular galaxy is thought to have been at one time a spiral or elliptical galaxy that was deformed by disorders in gravitational pull. Therefore, irregular galaxies have no distinct regular shape. Most galaxies occur in groups and clusters. Groups typically contain around 50 galaxies. Our galaxy is located in a group called the local group. Clusters can contain thousands of galaxies. A large grouping of clusters is called a supercluster and is considered the largest known structure in the cosmos. It's a natural function of cosmic evolution that galaxies often merge together to form a bigger galaxy. Our Milky Way galaxy is set to collide with the Andromeda galaxy, but that's 5 billion years away. Until then, other galaxies will continue to dazzle us with their mysteries millions of light years away.
For thousands of how-to and advice videos on any topic, visit monkeysea.com.
Okay, now you've watched the video, and I have here 6 questions that you can answer. Now, if you can answer it correctly for every question, you're going to get 5 points for listening tests. Okay, let's look at question number 1. Where does a galaxy revolve? Okay, you can write your answer there on the comment section. Where does a galaxy revolve?
Black matter.
For the one who answered black matter,
Is
can you
it-
give me your room number and your class number?
Narapasa universe?
Natapat sa mga universe. I cannot read color. The one who answered black matter, can you please give your room number and class number because I cannot read Thai.
That's his name. M6, room 6, number 7.
Okay. Room 6, number 7. So the black matter is the center of the galaxy and the universe revolve around the black matter. Okay, you get the point.
How many points?
5.
5.
Okay, let's move on to question number 2. According to the video, what is a bulge? What is a bulge? Okay, we will go a little bit. Nati, you identify first your room and class number. Nati, I cannot give the point if you don't. Okay, there is another answer here from room 5, number 14. Chadaton.
Sadaton.
Galaxy bulge is a tightly packed group of stars within a larger star formation. Okay, correct. Room Chadaton.
Room 5, number 4.
Room 5, number 14. Okay, you get the point. Okay, I got the answer already. Next one. Nati, I will also give you the point. Nati, can you identify? Okay, thank you for identifying yourself. Nati, why are you Matayong 9? Matayong 9?
It's grade M6.
Nati.
We changed it.
Okay, M6, room 8, number 21. Okay, because the black hole is also found there at the bulge. Okay, you get the point. Okay, let's move on to question number 3. Describe an elliptical galaxy. I have 6 questions here. Describe an elliptical galaxy. Sirawisit. Sirawisit. Room 8, number 12. Hanat, room 1, number 20. Okay. Who can give me the answer? What is an elliptical galaxy? Anyone? You can answer by describing how it looks like. How does an elliptical galaxy look like? What is the shape of an elliptical galaxy? Chotowit, hello. Room 8, number 39. Napat, room 2, number 1. Hello. Okay, I have an answer here from Natapat. Okay, type of galaxy with an approximately, okay, I can understand what you mean. With an ellipsoidal shape and smooth. Okay, Magellanic type, small spiral galaxy. Yes, it's like a Magellanic type of galaxy, correct also. Elliptical galaxy is a type of galaxy with an approximately ellipsoidal shape, correct? Who is this one? Seta Wood, please identify your room and class number. I cannot give the point because I don't know. Bondi Chai, elliptical galaxies has the shape ranging from egg shape to a long, narrow cigar shape. Very good. Room 1, number 29. Seta Wood, room 1, number 23, no answer. Okay, the following students get the point for listening. Room 6, number 24. Room 8, no. Natapat, I need your room number, please.
Setawut is room 4, number 23.
Okay. Chadatom, room 5, number 14. Yes, you have the point. Sarah Wood, where is your room number? Okay, Sarah Wood, room 4, number 23. You earned the point. Mondi Chai, room 1, number 29. Okay,
Natapat 68 to number 54.
no answer.
Ah,
Yeah, okay. Okay. So these students earned the points today. Okay, let's move on to question number 4. Irregular galaxies used to be what type of galaxy? You can give me 1 or 2 answers. Irregular galaxies used to be what type of galaxy? Okay, I discussed this earlier and it was also mentioned in the video. Soitong, spiral or elliptical, correct. Soitong, you get 5 points. Room 4, number 14. Your answer is correct. Okay. Next one. Question number 5. Describe. Okay, I have another correct answer here from Natapat. Elliptical, used to be elliptical or spiral, correct. So Natapat,
Room 8, number 54.
yes, 2 times, so 10 points. Natapat, very good. You earned 10 points already.
Teacher Sam is
Okay.
recording your scores.
Teacher Sam is he's recording the scores. Okay.
Full up,
Can you see Teacher Sam? He's here beside me.
just half of my face. No, never mind. In fact.
Okay. Okay, let us move on. Okay. Puzuk. Yes, your answer is correct, but I cannot record the point. Students, please identify your room and class number. Otherwise, I cannot give the point. Puzuk, what is your room? Class number? Where is this one? Okay, Puzuk is room number 3, number 26. Okay. Okay, let us move on. Question number 5. Describe a group of galaxies What is a group of galaxies? Anyone? Okay, I'm waiting for your answers. Describe a group of galaxies. Okay, I have an answer here from number 5, room 5, number 14. A group of galaxies is an aggregation of galaxies comprising about 50 or more galaxies. Okay, correct. Room 5, number 14, 5 points. So ito, contain around 50 galaxies. Correct? Room 4, number 14, you get the points. Okay. Do you have any other answers? Yes? Child. Group of galaxies containing about 50 galaxies. Room 1, number 29. Very good. Room 7, number 17. An aggregation of galaxies containing about 50 or fewer gravitational bound members. Correct. Okay. Let's move on to the last one. How are bigger galaxies formed? Can you answer the question? This is the last one. How are bigger galaxies formed? How are bigger galaxies formed? Natapat. Yes, it is the largest structure in the universe, but the question is how are these galaxies formed? Anybody? How are these galaxies formed? Natapat, yes, it was formed, it was formed as a part of Big Bang, but I need a more specific answer. How are bigger galaxies formed? No, universe is not the answer. So ito?
Galaxy merge.
Okay, very good. So ito, that is the answer. By galaxies, the merging of galaxies. Very good. Room number 4, so ito number 14. Very good. Bondi Chai, room 1, number 29, the merging of galaxies to form bigger galaxies. Very good. Okay, students, very good. Shane, more concentrated supernova? No. Okay, Natapat Samwang, galaxy merging together. Correct. That is the correct answer. What is the number?
Natapat, room 8, number 54. Yes or no?
Natapat, room 8, number what?
54.
Number 54.
Is it correct?
Natapat, can you answer? Room 8, number 54. Natapat, is that you? Yes, or
Yes.
no? Yes, okay. Up, he answered already.
Natapat,
Sorry, I cannot remember because there's so many coming in. Okay. What else? Okay. So, I'm going to move on now to the next topic, which is our Milky Way. Who can answer this question? What type of galaxy is the Milky Way? Anybody? What type of galaxy is the Milky Way? Okay, I wrote the question here. What type of galaxy is the Milky Way? Natapat again. Very good. The answer is spiral.
It's movie.
Huh?
Movie.
Movie? What is the number of movie? Movie. Spiral.
Her name
Movie.
is Moti.
Muji.
Yes.
Group number what?
She room 5.
Room 5.
Yes.
Movie, are you room 5? movie
ใช่ชดาพ
room
ร
5 can you tell me
Ashadaton.
okay Chadaiton room 5 number 14 okay very good the answer is spiral galaxy Napason room 7 number 6 room 7 number 6 Napason correct the answer is spiral okay Nati Star Dragon room 8 number 21 the answer is spiral galaxy correct okay I think I have no more answers okay let's move on yes YouTube again okay students okay this YouTube video that you're going to watch is not owned by me it's owned by YouTube and it will be used only for educational purposes okay students ready to watch another set of questions
See that strip of stars splashed across the night sky? That's our home galaxy, the Milky Way. You can see it from Earth because we live right on the outskirts, far away from all the fun stuff happening at its center. What would it be like to reside in its galactic downtown? What would our night sky look like? Would we get sucked into a black hole? This is What If, and here's what would happen if the Earth was near the center of the Milky Way. The Milky Way is huge, about 100,000 light years across. It has 4 large spiral arms encircling its center. That makes it a barred spiral galaxy, just like most galaxies in the observable universe. If the Earth packed up its belongings and moved to the heart of the Milky Way, things would be looking pretty bleak for the survival of any kind of life on the planet. But not because of the Milky Way's supermassive black hole. The Earth is located in a quiet neighborhood in one of the smallest spurs of the Milky Way, the Orion Arm. We've got approximately 27,000 light years between us and the galactic center. It's a comfortable spot to live in. The temperatures on Earth are just right to sustain life, and there aren't too many space hazards that could wipe out our existence. Well, I didn't say it's completely safe, did I? Living anywhere near the center of the Milky Way would be different. It would depend on what part of that center the Earth had the misfortune to occupy. The closer you get to the heart of the galaxy, the tighter the stars are packed together. Because of this high star density, the Earth would be blasted with a lot more radiation than what the Sun throws at you right now. Under these circumstances, the odds of life ever evolving would be pretty small. But if the Earth moved to the center, together with all its inhabitants, you'd find yourself very unlucky. Earth's magnetosphere wouldn't be able to protect you from space radiation blasting from all directions. This could change the Earth's climate and cause everything on the planet to either mutate or die. If you lived, your biggest concern would be a close encounter with a supernova. A supernova occurs when a massive star collapses, releasing radio waves, X-rays, cosmic rays, and gamma rays into space. For all we know, one massive stellar body could throw the Earth out of the Sun's orbit. Our planet would be surrounded by foreign stars until one of them exploded in a supernova and wiped us out for good. But it would look spectacular from Earth, if only for a brief moment. There's another big hazard that lies within the Milky Way's center, a supermassive black hole called Sagittarius A star. If getting sucked into a black hole isn't on your to-do list, consider yourself lucky. The Earth might stay far enough from it that we wouldn't get engulfed by this cosmic beast. But we could get close enough to get caught in the black hole's orbit. At a distance of 20 billion kilometers from the black hole's event horizon, the Earth could develop a speed of 25 million kilometers per hour. That's over 230 times faster than the speed our planet is moving at right now. So would that mean strong winds? More natural disasters? Would you end up flying off into space and right into the black hole? It sure wouldn't be good for you, or anything else on the Earth's surface. The Earth is perfectly designed to be right where it is. It can survive on the outskirts of the galaxy, but you wouldn't want it to be anywhere else. The most dangerous place for a planet to be located is anywhere near the center of a galaxy, any galaxy. If you just want a nice view, your best bet might be to teleport the Earth to the middle of a nebula instead. But that's a story for another What If.
Okay, you watch the video and then I have the last 4 questions for you to answer for points. The first question is very easy. How many spiral arms does the Milky Way have? How many spiral arms does the Milky Way have? Anyone? Just give me the number. Room 6, number 29. No, it is not 3.
4. So you don't say 4.
Soitong, 4. Okay, you keep on posting your answer because if I say it now, the others might follow. Okay. I see one correct answer already. Okay. Soitong, room 4, number 14, correct. Chataton, room 3, number 14, correct. There is somebody here who wrote in Thai. I don't understand. Please give me your room and class number. Natapat.
Room 8, number 54.
Natapat.
Yes,
Okay, correct.
The other guy.
There's one here who answered 10. I don't know who it is. Okay, room 3, number 26, correct. 4. Pusap. Rujanatham, correct. Rujanatham, what is your room number and class number? Your answer is correct. Nati, Star Dragon, room 8, number 21. Your answer is correct. Napason, room 7, number 6. Correct. Who can be this one? I don't know. The student who answered 4 is correct, but you wrote your name in Thai. I cannot read it. Okay, I got it already. Your Napatson, room 7, number 6, correct. You get the point. Natakrita. Hello, Natakrita. Your answer is 2. No, it's not correct. Okay, let's move on. Number 2. Which arm is the Milky Way galaxy located? Anybody? The Milky Way has 4 arms. In which arm is the Milky Way galaxy located?
Between the Sagittarius and Perseus arms.
Where is it?
It's room 6, number 7.
Okay, room 6, number 7. Okay, the answer is correct. Between Sagittarius and Perseus arms. Okay, you get the point. Number 7, room 6.
It's
Okay,
located in the first galactic quadrant. Plus up between the Sagittarius and Perseus.
Room 7, number 17, correct. Between Sagittarius and Perseus arms, correct. Please do not write your answer in Thai because I cannot read Thai.
Orion arm or Orion spur located Sagittarius and Perseus.
Okay, this one is also correct. Orion arm or Orion spur, located between Sagittarius and Perseus arm, correct. Room 5, number 14. Bondi Chai, room 1, number 29, correct. Located between the Sagittarius and Perseus arm. Okay, you get the points. Some of you answered more than 2 times. That's very good. Okay, next one. Number 3.
Number 3.
Room 7, number 6. Room 7.
Number 6. Number 6 you said.
Sagittarius and Perseus arm.
Oh.
Okay, number 3. Give at least 2 effects of living at the center of the Milky Way. What are the 2 effects? Okay, this is a difficult question, so I will add 2 more points to anybody who can answer this question. Give at least 2 effects of living at the center of the Milky Way. Okay, I will add 2 more points. So instead of getting 5, you're going to get 7 points. Okay, anybody? Just 2 answers for 7 points. I'm waiting for your answers. At the center of the Milky Way, we also have, you know that there's a bulge there at the center. And inside the bulge, you have the black hole. So, what do you think are the 2 effects of living at the center of the Milky Way? Students, take note that our solar system is located in one of the arms of the solar system away from the black hole. Any answers from our viewers? Okay. We skip that question first, okay? And if you have the answer, you can post it later. I will move on now to question number 4. Why is it we cannot get sucked in the Milky Way's massive black hole? Okay, this is question number 4. Why is it we cannot get sucked in the Milky Way's massive black hole? Okay, I will give you a tip. The answer is the location of our solar system in the Milky Way. Why is it we cannot get sucked in the Milky Way's massive black hole? Again, the tip, the answer has something to do with the location of the solar system in the Milky Way. Nat, hello, I can see you. Nat, room 8, number 21. Okay. Nat, you're the one from EP, right? We locate far away from the center of the black hole. Very good, Nat. You get the point.
6, 8,
Okay. 7 points for you, Nat. Ah, okay, she answered already. Yes, she is from EP. Okay, do I get some answers for question 3?
Natapat said no vacuum.
No vacuum? No, that is not the answer. My tip was the location of the solar system. Sorry, the location of the solar system in the Milky Way. Okay. So no more. Okay, we have here no, free Kang, room 7, number 35. Teresa, room 7, number 37. Hello. Okay, I have a few minutes left. Okay, we better move on. Okay, I have here another vocabulary. Maybe you've encountered this when you were younger. It's called the light year. Now, when we're talking about the universe, we don't measure time there in terms of seconds, minutes, or hours. We measure time in terms of light year. Now, a light year is the distance a beam of light travels in a single Earth year. So that means that it takes 6 trillion miles or 9.7 trillion kilometers for a beam of light to travel in 1 year. Okay, that this vocabulary I did not include it in the initial set of vocabularies because you will encounter it in the later part of the lesson. Okay, let's go now to the facts about the Milky Way galaxy. Number 1, this is a question I asked before. What is the shape of the Milky Way? It is spiral, and its rotation is 200 million years in its center. The number of stars is 100 billion, including dust and gas. Number 3, okay, as I mentioned earlier, we're not talking here of meters, kilometers, and so on. So the distance of the Milky Way galaxy, like if you're talking about the width, is 100,000 light years. It has a disk, okay? It means it's flat on the sides. There's a central bulge, and it has spiral arms. Spiral arms is a characteristic of the spiral galaxy. And the central bulge, where you can find the black hole, is about 12,000 to 16,000 light years wide and 1,000 light years thick. Okay, so these are the 5 important facts about the Milky Way galaxy. Now, there are other galaxies that I would like to discuss with you, like the Sombrero Galaxy, which I cannot do it because of lack of time. So that ends our lesson for today. I hope you've gathered some important information, even if you did not attend the class. So when you come back to school, when the school opens again, we will just do a brief review of this topic. Now, if next week I get to teach you again, I'm going to move on to the next topic on the formation of the solar system. Okay, bye guys. See you next time. Bye-bye.
Bye-bye, teacher Sam.
Teacher Sam, you welcome.
Bye.
Please looking for me.
Okay.